We're here to talk about containers and security. Who is using containers? Well, then you're in the right place. If you're not using containers, this is useless. No, but seriously, let's talk about what is a container actually, right? Because we try to mimic stuff from the real world into the software world. So a container is something, if you look on Wikipedia, it find out it's a receptacle for holding goods. That's nice. So that means a container can be anything. It can be something like this, your soda can to keep your soda or your beers in to preserve the flavors, to make sure that you can keep it for much longer than normally. It can be something like this, an airtight container to keep your food in, to preserve it there. Or as we normally try to see containers, these kind of things. And I know some people hate the shipping container when we talk about containers, and I know that person is also in the room. But the thing is, I want to see these things as boundaries. We use all these things to have a boundary from the outside world towards whatever is inside the container. Right? I mean, if you look at the beer can, preserving flavors. If you look at the airtight containers, preserving your food. If you look at the shipping container, preserving everything that's in there, so with shipping it doesn't get damaged. However, picking the right container is something that you should do. As in, it doesn't make any sense if I put my beer in an airtight container. Well, that might work, but putting it in a shipping container is worthless. Thing is, we see containers as something to protect the goods from the outside world, from influences. And that is a good thing. But if we are looking at programs, and if we're looking how we're using containers currently within software development, it's a bit different. So say we have this airtight container, and I put my Java application in there. Well, the thing is, it's not only preserving things from the outside world, because if it's in that container and it's just there, it's useless. I mean, we have to have interaction with the outside world. It has to have interaction with the outside world coming inside. I mean, connecting from a database towards your system or getting things out to the outside world with a REST connection or a browser or something like that. So pretty much it's a container with holes in it. Let's keep it to that. This means we cannot just say, and that's what people believe, hey, let's pick up our application, drop it in a container, and by default I am safe, I am secure. That is a misunderstanding because it is just another way of working. And you need to pick the right container, but also think of it from the right perception. This is me, by the way. I'm Brian. I am a developer advocate for Sneak. Tends to be a security company. We create security tooling, and I'm a developer advocate, which means I program less and email a lot. Now, seriously, they named me for some reason Java Champion. I do something with Java user groups, like the virtual Java user group. Everything was virtual last year, so who didn't? And some other stuff. But we're not here to talk about me. We're talking about containers. Let's take Docker for an example. Who uses Docker containers? Or use Docker containers? Cool. I'm taking Docker as the example because there are over 1 billion weekly downloads of container images. And that's a lot. And that's just downloading the images from Docker Hub. More than 1 billion weekly downloads. Okay, so by doing that, we're using these images a lot, and Docker containers are the de facto standard still for our industry. But let's get into 5 tips not to fail your security. I can name, I think, a dozen, but let's keep it to 5. Easy 5 things you can do not to fail your security when you just lift and shift your application to a container. Well, that's actually all the first problem, but let's not get into that. First of all, we talked about containers as in the real world. Picking the right container is a thing. What is the first thing you do in a Docker image or Docker file? What is the first line of your Docker file in 99.9% of the cases? From Ubuntu, or from Debian, or from Maven 3, OpenJDK 8, 17. In 2019, I did a small research on the 10 most commonly used Docker-based base images that are downloaded from Docker Hub that were freely available without paying for them because I'm cheap, I'm Dutch. No, kidding. The thing is, we scanned them for vulnerabilities. All these base images, this was the result. All of them had vulnerabilities. And as we are Java developers, and I can now legitimately pick on Node.js, which I love. Node.js was the one with the most vulnerabilities. But if we look closer at these images, we saw that it was actually not Node.js that was the problem. Because what I did was I just downloaded the latest at that point in time. At that point in time, Node, the latest, was based upon a somewhat outdated version of a full Debian distribution. Think about it. Do I need a full Debian distribution for my tiny, tiny microservice? Probably not. The thing is, because at that point it was Debian Jessie, I think, which is, okay, it's old now, right? But that full operating system layer comes with a ton of binaries, a ton of applications built in, a ton of stuff that can be triggered. And then you say, yeah, but I'm not using them. The question is, are you 100% sure? If you look at security vulnerabilities, it is not a never, almost never, a direct hit. It's like, say something is vulnerable, let's pick on that vulnerability, and then boom. No. We found an entrant somewhere, say, let's pick the obvious one, log4j, and then we call something, that calls something, that calls something else, and then in that loop, I finally can start a unauthorized SSL connection to the outside world. And then that binary is part of an attack chain. So, thinking about these things, it makes sense to see what kind of images you're using. If I'm just using the from Node.js in this case, yeah, that might not be the best trick. And if we look at, and this is the same research from 2019 already, if we look at different operating systems, we see that if you pick the same image but with a different tag, say from Debian to Debian Slim or to the Ubuntu version at that same point in time, you already get less vulnerabilities. And these are the vulnerabilities that come in through the operating system layer. And yes, as developers, we now need to think of that as well. Because it's not only our code, not only our dependencies, but also the environment that we ship with it. This is part of your code base. So picking the same image that you need or that you want to use, but with a different operating system layer, can already be useful. A few days ago, I did a test with Eclipse Xamarin. So I used to do this with adopt OpenJDK, but of course I needed to update my talk. So I went for the Eclipse Xamarin 17 JDK version. And what we see that there's a difference between if I do no tag at all, the latest one, which is based on Ubuntu 22, that had 18 vulnerabilities in the operating system layer. However, if I pick the CentOS 7 one, I have over 1,000. Would be more funny if it was over 9,000, but that's another reference. Anyway, picking the same application layer, or, well, I base this on Eclipse Xamarin 17 JDK because I want to use JDK level 17. Not because it's CentOS or Ubuntu or something like that. So picking that one, it makes a lot of difference by basing your image, for in this case Java, on a particular tag. If Alpine would be sufficient for you, then it would give you at this point in time, or actually 2 days ago, 0 vulnerabilities because there were at that point no vulnerabilities found in that Alpine version of Eclipse Xamarin 17. But what can possibly go wrong with container images, you would say, right? This is all theoretical. Well, is it? Well, some time ago, we were using an old, outdated, in this case it was a Node.js image, and it had a vulnerability in it. Well, it had a vulnerable binary in it. And some people are using these binaries. It was an improper input validation in a library that comes with Debian, in this case, ImageMagick. And ImageMagick is a library that you can use to resize images or do some things with images. it was so funny and it was so hilarious that they called this thing image tragic, because what we can do was magic, but in the wrong way. Anyway, the thing is, if I have an application, and I have this application running, say over here, I have an application running in Node.js, that this is just a simple JavaScript application, and it uses image magic, in this case, from the operating system, to resize pictures. And say I'm using my profile picture here, and let's resize it. Well, calling that binary in the operating system, and hopefully it comes back and it gives me the perfect size for a Twitter message. Fine, you would say, right? Nothing wrong with it. I have unit tests around it. Everything goes fine. But what if my image, and now I have to look at, looks something like this. I have an image, rce1.jpg. And it is possible in ImageMagick to upload JPGs like this. Did somebody ever look at SVG images? That you can actually describe the image instead of having it as a pixelated raster in it? This is pretty much the same thing. I am describing a graphical context in a view box, and then on the third line, I'm saying like, okay, call to an outside server to get the JPEG. And this is valid for ImageMagick. But the pipe says whatever that image is, or whatever that URL is, I am doing something else. Touch RCE1. So there's your code injection. By uploading this image, and it is accepted by that binary, I can do this. Like, if I'm looking in my Docker container, and I will enlarge it for you a little bit, at this point in time, there is no such file as RCE1. However, if I'm going to upload this picture, let me do this. It's probably in my exploit folder. And let's resize it. Then you will see nothing comes back because the image doesn't have any image data. Going back to this one, you now see that RCE.1 is here. So because this binary in this specific Docker image is part of what I use as features in my application, I now have a chain of attack. And it is not, if I would switch out the Docker image to a newer Docker image with a newer version of ImageMagick, this wouldn't be happening. But hey, I didn't know. I just used it, worked on my machine, ship it, right? Well, eventually this can happen. I can create a file. So I can also create a file with content. I can create a file with content, come back tomorrow, execute that file. Because, hey, with this way, I can basically execute anything. So I can just create scripts that do things. And without you even noticing what's happening, I'm having my Bitcoin miner launched up. With the current electricity prices, that's fun for you, or fun for me, not for you. And I'm mining my Bitcoins in the meantime. You get me? The point is, because our arbitrary code execution is in the end the thing that harms you, through a binary in your application or in your image, it's not something you want. Let's get back to my slide deck. Here we have it. So, okay, we're convinced that using the right image is a thing, and you seeing what kind of binaries come with that, and if I'm depending on these binaries, that we should do that. Then this seems natural, right? Only use whatever you need. So think about it. When you build an image, the first time you build a Docker container, or you build a Docker file, what did you do? I looked on Stack Overflow. How the hell does this work? And then it came up with something like this. Of course, I updated it to the newest OpenJDK version. What is wrong with this? The answer is everything. Because what I'm doing here, I'm creating a Docker image based on Maven 3 OpenJDK. So the full JDK. So I have Java, the virtual machine, and all shebang in it. Then I am copying my full project from my local machine into this container. And then I basically say, oh yeah, it has Maven in it. So I just said Maven Spring Boot run, because Done. It runs. Works on my machine. I ship it to the outside world, and hey, it runs. And actually, you're right. This runs. However, you know how large this image is. It was a tiny Spring Boot application with 2 endpoints. But it was 1.03 gigabytes big. Do we actually need the JDK? Maybe you need some parts of the JDK. Maybe you want some parts of the JDK. Maybe you want something like Flight Recorder or something like that. But in many cases, you do not need that. You do not need full Java in your theme. No. What did we do like 10 years ago? We built the artifact, and then we used the build artifact in our, I don't know, IBM WebSphere or something like that. Old days, back in the days, right? You didn't put the whole source code in it. Now we have an image that has Java, a build system, the full code, the whole shebang, and I'm only using this part, what's built. So, what we can do with Docker, and you probably know that, you can use multi-stage builds. And that's for a good reason. So let's change this image. Let's do this a little bit better. So, I changed this image from the upper part where I still use Maven 3 OpenJDK 7 to build my image, but I refer to it as built. I built the image with Maven package because that's all I need, and I don't test here because tests, why should I use tests, right? No, I did this already before, of course. The second step is, because that first image did build my application, did produce the binary, then I'm using something different. I only need a Java runtime environment, in my case. So I'm looking for the Eclipse Xamarin 17 JRE. This case based on Alpine, which is good enough for me. I'm going to my project folder, look at the actual jar, copy that, and says Java -jar. So I only have in this binary, or in this container, what I need. This also means my first part is only used during build time, and it gets thrown away. Then the final image is the lower part. And that image was only 270 megabytes, and it does exactly the same as the first one. But I don't have full Java in it, I don't have full Maven in it, and I don't have my source code in it. One thing that comes with this, if you use a multi-stage build, is that the first stage, or the earlier stages, are getting thrown away. They will not be part of the end image, the image that you end up with. So say I need something like, I need to put in credentials to go to a certain Maven repository if I'm not using Maven Central. And now I did it with a command line parameter. I can do this safely. If I'm doing this in my first image, then this will end up somewhere in that history. It is there. It is in that container. But if I'm using multi-stage build, it is in the first build. All that information is thrown away, and only the final build is there. So, what happens if you're not doing that? Say I'm able to get into your image, and you're using the full-blown Java 17 JDK with Maven. If I can go in, I'm actually able to change your source code to compile the image or to compile your application once again, and without getting the container offline, basically change your code, do something different, start it up again, because all my ingredients, the JDK, Maven, and the source code are already available. If you're just using the binary that you need, the artifact, like I'm doing here in a multi-stage build, you don't have that. You don't need that. So everything you don't need, throw that out. Make your image small. It's, first of all, a security thing, but secondly, if you're using with something like Kubernetes and you want to spin up different images at different times or be elastically scalable, it saves you a lot of space and startup time. Next up, who knows what the least privilege principle is? 1, 2, 3, 4, 5, 6, thank you. The least privilege principle is something like you only have the rights or the privileges to do things you need to do, nothing more. Think about it. If I'm in the hospital, and you will say, good for you, I have this time slot free so I can get more lunch, absolutely fine. But say I'm in the hospital. Do I want everybody in that hospital to know what's happening with me? Every nurse, every doctor? Probably not. Only the doctor that's actually treating me or the nurse that needs to take care of me need to know what I have, because it's kind of private. It's kind of private. So these kind of things you don't want to have all out in the open, and this means only the people that need to work with certain things need to know the things. Well, I know if you're developing, you probably say like, hey, let's get rid of all the certificates and let's run it as root, and like it's easy to develop. But if you shift that to production, that might not be the best case. So let's get back to our application that we just created, or our container that we created. It's exactly the same as we had before. Trick question, or question. It shouldn't say trick question, I should say question. What is the default user a Docker container spins up with? Who knows? Who knows what the default user is when you spin up a Docker container and you're not specifying any user? It's root. So it means this application has elevated privileges within that container. And that's not something you might want. I mean, if there's nothing in that container, fine. But you probably don't want that somebody can interfere with system variables, with environment variables. Hey, there might be some binary in it, because, so if I'm in there, all doors already open. Now, what we want to do is we want to create a specific user for this application that has the minimal rights to do everything it needs to do. So we only need to look at that second part of that multi-stage image and add a few lines. Done? Now seriously. These are the lines you need to add. And this is an Alpine image. Be aware of that. So if you're using an Ubuntu-based or a Debian-based image, the lines might be a little different. But what I'm doing here, I am creating a group and a user with actually I'm creating a dedicated system user with no password and no home directory and actually no shell access, because they don't need it. Then in the second line, I give ownership to the project folder that I need, because that's where my jar lives. And then the third line is the most important line, actually calling that user. Because from that point on, everything that is called is done with that specific user I just created. So now I don't have elevated privileges anymore. Now I have only the privileges that I need. Also look at, if you're using a base image, like, and I know that Node.js, for instance, has already predefined users. It's not well documented, but they have predefined users. Not thinking like, okay, I'm using Node.js or whatever image already in my from tagline. By default, it's fine. No, you need to call it. So that third yellow line, user, whatever it is, you need to call. If you forget that, everything else above that was useless. So make sure you create a user that has limited privileges, or look up if there's already a user with limited privileges and actually call that before you, in this case, connect your entry point. This is all clear, right? Let's get to the next one. Scan your Docker images and Java applications during development. Thing is, we are used to create Java applications. And if it works on my machine, I throw it over the wall to my operations folks and say, now it's your problem. Go to production with it. Unfortunately, nowadays, we pretend to do DevOps. Let's be honest, who actually does DevOps? Now, we try to do DevOps all. Sure. So we need to take care of not only the image or the application, because these things are intertwined. If we'll look at, we did this in our state of open source security, and this was already from a 2019 version, and we asked people like, when do you scan your Docker images for operating system vulnerability? And 50% says we don't. That's reassuring. What about this? Oh, let's actually first hack something. I think that's funnier. So say I am having an application, and this application runs in a Docker container. Shall we go into the application, or shall we go into the Docker container first? Let's go into the Docker container. We were at Docker containers. It doesn't matter what kind of application is in that Docker container because I'm not attacking the application. I'm not using the application whatsoever. I'm actually attacking the Docker container. So let me look at what the Docker container looks like. This is the other one. This one is running. Cool. It's running over here. Let me show you the Docker container, or what the Docker file looks like. So this is my Docker file. As you can see, it's a bit of an old file, and I'm using a multi-stage build with the first part is Maven 3 JDK 8 Slim. Cool, does some things, and then I'm using this one. Tomcat 8.5.2 because this creates an old-fashioned WAR, and I need a application server to run it. In this case, Tomcat. So I'm using Tomcat. Fine, cool. But this is an old version of Tomcat. And this version of Tomcat, we found out, had a vulnerability. An arbitrary code execution, once again, because these are the most fun. What it does is the following. So I don't have to go in the application, I'm just going into the Tomcat thing, and it says, hey, it was possible to upload a JSP file to the server via a specially crafted request. This JSP file could then be requested, and any code it contained would be executed on the server. So regardless of what my application does, how good my application security is, what kind of privileges my application has internally, I'm just attacking your Docker container. Good luck. So let's try, because this is my favorite database, the exploit database. And there's already something available for me. This is a Python script. And this Python script creates that specially crafted request for me. And the first thing it does is creating a JSP file with this output. A simple out-println with all A's to see if it actually evaluates to all A's on my screen. Fair. If that works, we're going into the second stage. And the second stage is basically creating a form. And that form has a text box and a button. And every time I put submit, it does this. Runtime.getRuntime.execute, which basically gives me a web shell. So let's try. Let me see where it normally should be. I think it should be normally at let me check. The to-do list is there. I think it's poc.jsp. Does that exist? Does not yet exist. So let me see if that works. I have the thing, that script that I showed you, loaded here. So let's execute the first part. It says something like poc.jsp. Cool. So poc.jsp, does it exist now? Oh, it's with a capital. It says it's not with to-do list. So it should be poc.jsp. Boom, all A's. So it executes. So without touching my application, I was able to inject the JSP file. All A's is not really fun. Let's do the second part. And this one is opening a web shell. All right, let's see if it's already working. And that should be pwn.jsp. Nice. So, well, you saw the Docker file, and I didn't specify any user. So, in this case, I'm Ubuntu because it's based on Ubuntu, which pretty much says I'm the root. Interesting. So I can do all sorts of stuff. I can do something like what's there, create a file with content, or even worse, might be able to set up a reverse shell attack to my own machine and take over that because I already know I'm root. Well, I'm root already here in the web shell, so I can do everything. Which is funny, so without looking at your application, without touching your application, I am just attacking the layer below that, which is your environment. So we should take care of that. And if I would have scanned whatever image I was using, and of course I did that on my local machine, and I did that over here. Let me enlarge this. And of course I use the tooling from my company, but there are more tools that can do that. But it says like here, I'm using Tomcat 8.5. Don't do it like this. It says I'm using Tomcat 8521, which has over 730 vulnerabilities. And if I would do a minor update to 8579, I would reduce it to 110, which is still a lot, but it would get rid of this one. And this one was the most vulnerable one. This one was the most critical one in this image. So by just updating these minor versions and doing this over time, I can check if my container is still solid enough. And if there's nothing found that can be harmful, like this thing. All right. So one thing you can do is you can either pull a base image and say, hey, I test that image. And that's a good way of starting with your whole Docker journey to see if that image doesn't already contain a lot of vulnerabilities before you actually use it in your Docker file. And you will get something that I showed you here. It will show you what the problems are, how severe they are, and why, if there is another version available that has less vulnerabilities. And you can do that also with your own application. Like, hey, I'm creating my own container, I can be creating my own container image, and I can use that, and if you, in this case, connect your Docker file to it, we can give you remediation advice on, hey, you're using 8521, go to 8579, that gives you less vulnerabilities. And we can do that all sorts of ways. But the thing is, you need to do that. You need to check these containers because these are part of your code base now. Then we go about your application. Who was here this morning for the talk that Brian Demers was giving? Brian Demers himself. That's fine, because now you see this slide. And I was discussing with him like, hey, you have a slide like this. I created that one with a colleague of him. So it was fun to see my own slide back. Say this is your application. This is the binary that in this case is part of your Docker image. How much of that binary is your code? What do you think? This, huh? Yeah, like this. And we take good care of that code. I mean, who does pair programming? Okay, the rest of you does code reviews. Thank you. Appreciate that. No, but we have things in place. Code reviews, pair programming. Well, you can think of how we should do code reviews. I'm taking a sidestep here because I've been in companies where it was like, hey, we got 20 minutes until we demo this to the customer. Hey, junior in my team, I've got this pull request with 500,000 lines of code. You can review that in 20 minutes, right? Took me 3 weeks to work on. You can do that. No, seriously, code reviews are a good thing to do if you pick the right person and give them enough time. Don't talk about, no, this semicolon should be on a different line. That's not a thing. Linters can do that for you. Actual code reviews are valuable. You should take time for that. But we take good pride in that part that is our own code. Code reviews, pair programming, we have QA, linters, stuff in place in our pipeline that checks it if the code is valuable, if the code is maintainable and scalable, and maybe even secure. If you don't do that, I can help you out, but that's a whole different topic. What about the rest? What about that yellow part? How are we looking at our dependencies? Have you ever looked at your POM file or your Gradle file? I've worked for one of the bigger banks in the Netherlands, and I found out a POM file that has over 2,000 lines of code that was the dependency block. It had 3 different XML marshals in it, and I don't know why, because Java has them already. Why should I use an XML marshaller from the outside world? Actually, nobody knew, because what happens is it came in, somebody built something on top of that, and then another person needed to do something else. Was like, I'm not familiar with this library, I'm not going to touch it, I'm using the other library, and you're building up. We actually didn't know even if some of these dependencies were still in use or not, or where they were used. That's harmful. And that is 80 to 90% of your code. And if you look at what the problem is, and let's focus on the middle column, Maven Central, or on NPM for my case, the problem is not on the stuff that you pull in. The stuff that you pull in, say Spring Boot Starter X, that has no vulnerabilities because a Spring Boot Starter is nothing more than an empty jar containing a POM. That contains a shit ton of other dependencies, the so-called transitive dependencies, because libraries bring in dependencies, and it goes several layers deep. If you're using Maven, just do Maven dependency, :tree, and see what actually that tree is, what comes in, what brings it, what by default, what gets into your application. Most of the problems are not in the things that you actually imported by hand, but that you depend on by accident or, well, without knowing it. And what can possibly go wrong in my application, you would say? Well, I have the same application I showed you in that Docker container, but I wanted to spice it up. So this one is running on, at this point, a still free tier of Heroku. Look. It's still running on Heroku. It's still there. The free tier is still there. Thank you. Yes, I need to port this one. But for now, it works. I don't have to go into that application because this application is using a outdated library. We're in the United States, so I hope everybody knows this company. Who knows the company Equifax? Yeah, it's a crediting company, right? You know what happened to Equifax in 2017? Yeah? Well, they're using Apache struts too. Didn't look at whatever was in production, but it just kept on building new stuff. The hack was in March, or the problem was found in March. There was already patched. There was a new release. The hack was in May of 2017. Then it took 75 or 76 days until they found out somebody was in. And bottom line is over 140 million customers were compromised, and it cost them about $2.1 billion at this point, not counting in any brand damage. Thing is, that Apache Struts 2 library, I'm using that as well. And I'm going to show you what can go wrong. So I'm using Apache Struts 2, that outdated library version. And, well, what I can do is I can hack that using a specific header in a curl request. And this is the header. This one. It's a content type. And who recognizes this content type? It's an invalid content type. And that's the problem. Because it is invalid, you went into some sort of exceptional flow. And in that exceptional flow, for some reason, don't ask me why, you were allowed to utilize OGNL, the Object Graph Navigational Language, which is the specific expression language in Apache Struts. And with that expression language, I could do all sorts of fun stuff, like calling certain methods on certain objects, or even better, I can create new objects, or in this case, the new process builder. And the process builder, I'm saying spin up a bash, and if I'm giving that bash and any arbitrary command and rerouting, in this case, the output stream to an input stream, I can make it visible. So let's do this. Let's use this one. I'm using the environment variables. So what I'm doing here is I'm using that header I showed you, and I make a substitution. Instead of the word command, I'm using env, which is the command to show you the environment variables on a Linux-based operating system. And localhost doesn't work for me because we are on Heroku, so I said, so let me copy-paste this. Let me go into here. And let me try this. Let me see if this works. Hopefully, anytime now. Man, please, come on. Let me try that again. Oh, it's still in limbo. It should work. I think my Heroku pod doesn't want to play with me today. Anyway, it is possible. It is possible to go in and to actually show you the environment variables. Well, that's not a good thing. And it means that if I can show you the environment variables, and hopefully it spins back in a second. If not, you just have to believe me. I could show it later on, or I have it on tape somewhere, one of my earlier talks. The point is, if I can call an environment variable, or I can call anything in this, I am also able to create a file with content, execute it tomorrow, etc., or do something different. Unfortunately, it doesn't want to play with me, so let's move on. One of the other things you need to do when you're building Docker containers is you need to build it to rebuild it. And that sounds weird, but a Docker container essentially should be something that you can throw away at any given time. It should be disposable. Who's working with Kubernetes? well, then you definitely know it should be disposable. Or you have a whole lot of admin on your Kubernetes cluster every single day, which also keeps you into a job. I get that. But say I have my Java application and it is in a Docker container. Well, I probably don't want one instance of it. I want 3 instances of it. So I spin up 3 of these instances. And let's say I have good logging and real-time alerting in place. And I found out that in one of these pods, something fishy is happening, and somebody is in, or I assume, or I think somebody is in. The first thing I should be able to do is blow it up, get rid of it, because then the immediate threat is gone. If I'm not able to do that, and your system is down, then you have a lot of other cascading problems. What I'm hoping there is that I can spin up a new one, and hopefully it was a one-off. I can investigate, and because I have my alerting on, I can see if it happens again or not. Hopefully I can spin it up, or I can spin it up with a newer version. This means that you have to be aware that something should not be in your Docker container. So lifting and shifting, as some people or some companies think they can do, should not be a thing. Things like persistent logging, of course, your database, or caching should not be in your container, but should be outside of your container. So if you build for security reasons or for any reasons, make sure that these things are there, because if I blow up my container and I want to know what actually happened, why that person was in, what happened, which endpoints were vulnerable, but my logging is in that container, then it's horrible, because I cannot do a postmortem anymore, because it's gone. So make sure that you build something like this, or use something, if you do use caching, you use a in-memory data grid like Hazelcast or something like that to make sure that you can just blow it up and spin it up again. Because did you know that 44% of the Docker images can be fixed by just putting a newer base image in it? And if I'm able to do that, if I found out that I have a problem with my base image, switch it out, spin it up again, not even touching my application, I can already get rid of a ton of potential problems, and every potential problem is something that can hit me. We ask people, how do you find out about new vulnerabilities in already deployed containers? And most people say we don't, because hey, it's in production, it's not my problem anymore. It's an ops problem, and I'm a developer. Well, again, we pretended to do DevOps, right? 20% of Docker images, the Docker image vulnerabilities can be just fixed by rebuilding the same image. And why is that? Well, that first line, for instance, a lot of people are saying from Ubuntu, and for this case, I say latest. And we can debate if that is a good thing or not. I'm not, well, I am on a side, but I'm not going to getting into that. I would say don't do this, but make sure that you have a, well, basically you use the SHA hash, that you have a deterministic build, and every time it's the same thing. But some people say it's hard, and I just want to be sure that I have the latest. Fair. Let's not get into this. But if I'm doing this, only the first line, Ubuntu latest today or 2 weeks from now, is a different image. I am 100% sure of that. Then the second line, I'm using in this case apt-get to install Python or whatever. The version 6 months ago is different from the version now. So just rebuilding this gives you new binaries. And these binaries are often fixed, patched, or at least don't have the same mistakes less mistakes, hopefully, less known mistakes, I should say, than the ones before. So rebuilding it should be a case. Even if you do not touch your application, just rebuilding it, if you choose to use the latest image, please rebuild it often. Say, depending on how vulnerable or how important your system is, daily or maybe weekly or maybe monthly, depending on your context. And if you're building that, please use the -- no cache flag, so you're absolutely sure you're not using anything that was already on that build machine. Easy. Well, let's sum it up, because we are already almost at the end of this talk. The 5 things were: choose the right base image. Choose the right base image that actually fit your application. Choose only what you need. Do you need the full JDK? Do you need Maven? Do you need your source code in your image that goes to production? Probably not. Maybe a Java runtime environment, or a Java runtime, I should say, is enough with your build artifact. Don't ever run, please do not run your applications as root. And that is the default, unfortunately, for Docker. If you're using Podman containers, it's already different, I know. And if, in some cases, if you're using some managed Kubernetes clusters, you're not even allowed to spin up Docker containers that run as root. But if you do, if you're just using plain AWS or Google Cloud or with a barebone Kubernetes on it, be aware that this is a thing. Of course, you should also care of the rest of your Kubernetes cluster, but don't use the root user by default. Scan your apps and images. That means either on your local machine, but also when they are already in production. And when they're already in production, you know what the dependency tree is. You know what the base image is. So if you scan that on a daily basis automatically, and I can do that for you, and ping you whenever things go wrong, that is nice. That doesn't mean you have to do it every time by hand, but automate it. And make sure that when something goes wrong, you can make an educated estimation. Do I need to do something about it? But you need that information. And always build your application to rebuild. Just lifting and shifting your application is not a good thing. Make sure that you can demolish that one Docker image or that one Docker pod or node if you need to do that. If you want to know more, we created 10 best practices for you. These were only 5. One of the things over here is, make sure that the Java version you're using is actually Docker aware. The older Java 8 versions were not. And if you want to know more about how to be efficient and effective with Docker, I would love to point you to this talk by Bruno Borges from Microsoft. It's about performance tuning in Java with Kubernetes. But the first part of this talk, it was a talk that was like 2 weeks ago. I saw this on Java Zone in Norway. And he spoke about why you should tune your garbage collector for your Docker image because things go wrong. How many resources should I give my Docker image to be effective? So if you want to go one step further and not only be secure but also effective, I would recommend to watch this talk and go deeper into that. So far, so good. Enough about this. I want to thank you for being here, and I hope you enjoy the small remainder of Jconf. Thank you.